In this video, we're going to start talking about polynomials. More importantly, we're going to look at a set of data and use it to try to identify what is the degree of the polynomial. We're going to do this by this process that we call finite differences. Finite differences basically is we're going to start taking the differences. We're going to do this a finite number of times. We're going to see how long it takes to get a constant value when we're taking differences. So here's my first set of data. To find these differences, if you remember back from when we started this, beginning of this semester, beginning of the year, we defined the difference as now minus previous. So when we do this difference, we're going to do -2 minus a -22, or 20. So 6 minus a -2 is 8. 2 minus 6 is -4. -14 minus 2 is -16. -42 minus a -14 would be -28. Now when we do this, we see we are getting different values when we find the difference. It's not a common difference for this case. So we're going to do it again. Let me just move this number over. And let's find the difference. So we're going to take 8 minus 20, -12. -4 minus 8, -12. -16 minus a -4, -12. And finally, -28 minus -16, -12. This case, we get a common difference. So this is what we're looking for. We went through and said, here was my first difference. It didn't do the job. The second difference did the job. It's a constant. That means that this is a second degree polynomial. Or a quadratic. So now we're going to use the calculator to find what is the equation of this second degree polynomial. What's the equation of this quadratic? So let's get out the calculator. I already said junk. So to find with the calculator, to find the second degree, we know this is quadratic. So we need to work with the data. Anytime you're working with data on the calculator, you're going to use the statistics function. So go ahead and we press the stat button. When we do this, we get up our stat menu, our first menu. We are going to edit the data, so we will enter the editor. And that should bring up your list editor. And you'll get you put your data, your x's, put into L1, y's put into L2. So I would pause the video while you type these into your calculator. Once you have all that data into your calculator, you're going to go ahead and hit your stat button again. This time when you get to the edit, to your main screen, you're going to go to the right to highlight calculate. And you'll bring up the calculate menu. And since we know we want a quadratic, we're going to come down and do this quadratic regression. So option 5, so you can either arrow down to 5 or just hit the 5 button and bring up your wizard. When we get this wizard, we're going to list where are my x, what is the x data, where is the y data. If you put your data, as I did, in list 1 and 2, for list 1 we should have L1, and for Y list you should have L2. And again, if you need to change those numbers, if you notice, that's going to be the second function on the numbers 1 through 6. So if you want L1, you're going to go second 1 to get L1. So we have L1 for the X list, that's where we put the X's, L2 for the Y's. Frequency list should stay blank. We don't really need to store the regression equation on this. If you want to, you can. You're going to use your alpha trace to bring up your Y options and store one in there. But go hit calculate and enter. And that should bring up the screen. So we say here we did a quadratic regression. A quadratic, as you notice, is going to have your x squared. So ax squared plus bx plus c, and it gives you your values for a, b, and c. So your final equation is going to be y equals a negative 1.5 x squared plus 7x minus 2. If you know what the degree of the polynomial is, the calculator can take the data and fit what it thinks is the best equation of that degree. But it's going to take the degree you pick. So that's why you need to have a way to say, what degree do I want to try, instead of just guess and checking. So let's try a couple more. So here's our next table of data. We're going to start off by finding our differences. So 2, 9 minus 15 is negative 6. 1 minus 9 would negative 8. We got negative 4. We got 6. And we got 22. Obviously, those are not the same. So we'll go and find the difference again. Negative 6 minus 2. Negative 8 minus a negative 6. Negative 4 minus a negative 8. 6 minus a negative 4. And 22 minus 6. Again, we don't have a constant, so we go a third time. Negative 2 minus a negative 8. 4 minus a negative 2. 10 minus 4. 16 minus 10. So we see here is my common difference. And we have my first try didn't work, second try didn't work, third try did work. So this is a third degree or a cubic. So now take a second to plug this data into your calculator. Go do a cubic regression on this data and see if you can get the equation for this data table. You should have gotten this equation. Y equals x to the third plus 2x squared minus 7x plus 1. And you can always check to see how good your equation is by plugging these numbers into the equation. Or put this equation in your equation editor and make a table and see if your table matches up with this table. Let's do one more. With this table, let's go through and do the differences again. It looks odd at first that there's no way that would come up nice, but if we go far enough, we will see first try doesn't work, second, third doesn't work. On the fourth try, we will get this to work out. And again, we can plug this into the calculator. This is fourth degree, or it's a quartic. Whoa! And if you plug it into your calculator and do that quartic regression, you will get the equation is y equals x to the fourth minus 5x squared plus 4. This will work as long as you have enough data that gets you to a point where you can find that common difference. But the other thing is we have to have the difference in x has to be constant. It doesn't, though, always have to be equal to 1. Because if we go back to our first set of data, you notice here my x is changing by 2 each time, but it changes by the same amount each time. As long as that's happening, we can use this process of finite differences to find the degree of a polynomial. Once we have the degree, we can use technology to help us easily find an equation for that.